Okay, so we got up to step 6 um, in our last channel video where we digitized our banks and our cross sections and we put everything into the model. Remember, I use extra cross sections just to help define the positioning of the cross sections in those curvy areas. That's not necessarily, you don't really need that many cross sections because it's pretty uniform, but I did that anyway. And now we have to apply those cross-section attributes. In this case, I just use like a 0.3 or 0.03 or 0.032 or whatever, whatever you think is that you want to use as an end value in your channel. And you can just apply that right here using the attribute table. Now we need to fill the data out in each of the individual cross sections. So this is a bit more time consuming. So I'm going to just start by saying, how do you get the data or how do you get channel geometry? Because in the West, most of our channels are dry. So we can just grab canal or channel data. Well, not really canals. We have drainage channels mostly. We can just grab that data from the LiDAR. We can just use these guys right down here and we can just sample that data right off the LiDAR. But because these canals are always full of water, we have to determine what the cross section is. So you can use a trapezoidal geometry and just, get that, like maybe that as-build data, and your as-build might have your elevation in it, or you can measure the data off the map with the tools in GIS. Sometimes you can go into like bridges and things and you might be able to get some bridge data. Like you might be able to get some bridge data off of like a bridge report or something. So you might be able to get data off these sites without having to go out in the field and survey data because they're just canals, right? They're standard. So they typically have standard elevation data associated with them. Or you can just go do a site visit, tool around in there. But if you are a typical Floridian and you do enough fishing on these canals, you kind of get the sense that they're all really uniform and they're all kind of designed the same because there's a standard. So that's what we're going to do. We're going to take what we know from the map and we're going to apply a little bit of what we know about the weirs and then just apply a bed elevation to that. So what I have done is I've already done that. And I've already created each one of those individual cross sections and put it into the project report, or sorry, the project data files. So for every cross section, all 32 of those cross section, I have used a combination of data snapped off the map, estimating the bottom elevation of these upper channels, and then getting the bottom elevation from the cross section data that I had from the other run for the more natural area of channel that's down in the lower sections. So let's take a quick look at some of these. So what we're going to do is grab these data, open these files, and then we are going to open individual files, select the data and copy it, and then close the file. And then we're going to add that data into the table for each individual cross section. And so let's go ahead and just start that right now. Back in here, we'll want to go to cross section 1. And you can see right now it's got its placeholder data. So I'm going to open the text file on the other. Oh, that's funny. This is from the video, or this is from the, I got to take this out real quick. This is from the pictures I was taking to help you understand how to do this. And then I'm going to take out the tabs. And then one more tab. Okay, so that should get, no, one more tab. Okay, and then just put a 0 in there. Okay, so now the data is ready to go. So we're starting at station on the left in feet and elevation on the right in feet. And then this value for this cross section, I kind of estimate based on given slopes and I know some things about the weirs. I know like some of the base elevations of the weirs and the crest elevations of some of the weirs. So I can kind of estimate the dimensions of this channel, even though I haven't been to this channel before. So I'm going to Control A, copy that, and well, then I close it. Just close it. Don't leave it open because you'll just forget about it. Yeah, I'll go ahead and save that too because I did make a good change to it. And then come over here into cross section 1 and paste it. And then you use your roller wheel to get you down to cross section 2. Open cross section 2, Control A, copy, Control C, Control W. Just keep that Control key held down, paste. So it's that simple. Then you go to the next one, cross section 3, and again, I'm going to open this, and again, I'm going to keep that Control button down, Control A, C, W, and that will just get that data and close that file so I don't accidentally, get it again. Control. Then we go down to the next one, 4. I'm back over here in 4, ACW, paste. And you can see that they're changing. Individuals are changing as we go. Control ACW, and that is 5. And again, I'm using the roller wheel to change the cross sections. Whoops, you can't Control V. There's no Control V in these tables, unfortunately. And I'm going to finish out the rest of these, and then I'll come back to the video, or I'll unpause the video once the rest of these are finished. Okay, I am down to my last 3 cross sections, so I just wanted to finish out these last 3 cross sections in the video. So if you go to cross section 30, over here, you can see that I've done a really good job of tracking it because my blue line always stays on the cross section I'm on, so I know to go get the next one. ACW, make sure to close that file so I don't have a bunch of those open. Move down to the next cross section 30, put your cursor in the station and paste. It's taken a little bit longer now that I have a bit more data in here to paste those. So I'm having to have a little bit more patience. They go really fast at the beginning, and then as you get more and more data in there, it takes a bit more time to put it in there. Because it actually does a few things when you're pasting the data in. It doesn't just paste the data and plot it, it does other things as well. And then the very last one is number 32, and ACW, last cross section. And I also wanted to, so you can see as you go up through here that my cross sections are pretty uniform. I don't have those, and if you look at the data in here, I'm going to take this off, and I'm going to zoom in here, and if you look at the data, yeah, there's some sandbars in here for sure. There's some deposits in here. However, these are alluvial sandbars, so they're always reworking themselves, especially when we get high flows coming through here, like from a storm. So these sandbars are going to rework themselves, and these cross sections are not going to hold their shape. So the reason I don't bother trying to get a perfect cross section in here is because I'm more concerned with getting the capacity of the channel. And if the water is moving fast enough down this channel that it can rework these bars and move that sand around and mobilize that sand, then it's going to be basically the capacity of the channel will be a little bit more realistic if you represent it like this. So that's why I don't try to get these bars perfect in here. Now, let me tell you how I got this data. Okay, so up in here, I took and I sampled from all of these cross sections, I sampled the elevation raster with all of the cross sections. And then I came down in here into the canal, and anywhere that, that my water surface elevation from that raster right here is like, let me grab it. Oh, sorry, I have to actually click on the raster. 5 feet. So the water surface elevation right here is 5 feet because the tide gate holds it up in the dry season. The tide gate holds it up. So when they flew the LiDAR, the water surface in there was 5 feet. The banks are around 10 to 15 feet in here. And so all I needed to do was get that, drop that down and get that kind of shape of the channel. And then I just estimated using the slope of the system. I take the slope of the bank and I backed out a depth, or sorry, yeah, the final depth right here. And I got my final depth was around 2 feet, 2 feet in elevation. And then at my weirs, I didn't really know what's going on in these weirs. So I just assumed a bit of a drop structure across this weir, and I gave it a 1/2 foot drop structure. So you can see that when we open this channel up in the profile, you'll be able to see that. So I did that drops with both weir, and the rest of this I just tried to apply a uniform slope between these cross sections and estimate the bed elevation from what's happening at the two weirs. And then the rest of the data I had point data from a mic model, and I knew my slope, so I back calculated out my slope up to, there's one slope between this part of the channel and this part of the channel. There's one, it's a steeper slope, and then up here it's a really shallow slope. So I had two changes in slope right in this area, and it actually, I think it's like right around in here, there's that change in slope. So it worked out fairly well. And then the slope in this area would be determined by these points. And so I just tried to grab these bottom points along these little cross sections right here. I tried to grab out a bottom point from these cross sections, apply that as my bed elevation, and gently push it upstream, even though we know with all those sandbars that it's really that sloping down in this area isn't a perfect gentle slope. It's kind of going up and down to those sandbars. But when the river starts to flow at flood stage, those sandbars are going to rework themselves and they're going to get mobilized and pushed around. So I'm not going to worry about trying to get a perfect cross section in relationship to those sandbars. I just want to get the capacity of the channel so that it can move water through the system. All right, now okay, so that's done. Let's get back to the next step. So all of the cross-section data is in, and the next step is to schematize the channel. So this is pretty simple, but I will say that if you find that you get an error message with your schematizing, it's generally because one of your cross sections isn't crossing the left or right bank. So go ahead and make those cross sections wider than the left and right bank, except for that first one, obviously, when you're doing your own channel. This channel, we're going to go based off of my data. And then here's that schematize button right here. And while that's schematizing, I'm going to close the ID. Well, I'll have to click OK. I'm going to close this window just so we can see things a little better. And I want to come in here and I'm going to start to simplify my map. So I'm done with this data down here. And I want to show you the difference between a left bank line and a right bank line. So I'm going to deselect all features. And now I will turn off these guys, the left and right bank, so you can see that my schema bank follows the center line of the grid. So it's never perfectly aligned to your bank because it has to be assigned to the center line of your grid. So what you can try to do is keep your blue line kind of up here out on the bank where possible, and it looks pretty good. So yeah, you can see sometimes, and then if you have some alignment issues, like this one's fine, even though it's not up here, but there's houses and stuff up here, so you gotta be careful about that. Well, I think it's actually a roadway, so that would be fine. But down here further, there's houses, but this is okay. It doesn't look bad, and it does follow the center line, so it's never going to be perfectly aligned to the bank that you draw. That's okay. There's some leeway in there. And let's see, let's get down here, and I want to show you a couple of things. So it's okay to share banks like this. That's okay to share, for the right banks to share, but not on the left-hand side. It's not okay to share on the left-hand side. And then sometimes you might see that things get a little funny, like right in here, they kind of change their direction. That's pretty much okay because these will be kind of included as a bank and won't be a problem with the channel. Right in here, we can lower cross-section data right in here and allow water to come in and out of that. That's okay. But it's such a low bank, it'd probably do it anyway. And then here we have, again, I have tried to reposition these cross-sections so that we're only getting 2 of these and only 2 of them are sharing as we go around that tight bend. And here everything is looking okay. The main problem you'll run into with building a Flow 2D channel is that when you go to, yeah, this one right here, I might like this cross section right here, I might take this one and go this way with it a little and take this one and go this way with it a little, but So far it looks okay. And note where my cross section crosses my blue line is always on an area where there's high water. So remember, when I snapped that data off that cross section, let me get down here to one of these and see kind of where we are. Let's go down here a little bit further. Yeah, let's get this one right here. So when I draw this cross section and I snapped the elevation for the part of the cross section that was, LiDAR data, represented by the LiDAR data, it takes the station elevation from right here to right here. So it bases it off of these two lines and where they cross your cross sections, and that's where it samples the elevation from. So if you be careful and you place these cross sections in a decent location so you're getting good bank data, it works much better. And then of course in this case, again, this weird, I don't know why, but this stage right here, let me grab is like -4 feet. I don't understand why that is. I don't know that there's a tide that gives you -4 feet in this area. So maybe we'll understand more about that when we get into the class and talk to some of the other engineers who know the area better. But I talked to the people who owned this marina right here, and they say that it goes between the water surface elevation goes between like half a foot or maybe -half a foot and 2 feet, and that's kind of their high tides are around 2 feet. And I validated that data from the tide control that came off of NOAA's tide prediction. So that's just an oddity about that LiDAR data. Now let's see, the channel has schematized and it looks pretty good. So the next step will be probably to interpolate it. So let's see. Oh, actually the next step is like to check your bank alignment. Yeah, review your bank alignment, and then if you have any places along your bank that aren't quite right, just make an adjustment of that left and right bank line and hit the schema button again. It's that simple. You can actually edit all three of these layers at once, and you can move when all three of these layers are in edit mode. You can set the vertex tool to modify all three layers at once. So you can just come in here and make mild adjustments to this. I'm not going to do it, and you don't have to do it because I already did it for you. But when you go to do your rail channel, I've got all kinds of great videos on how to do this in my other channel modeling stuff in my other tutorials. Okay, so once you finish your realignment, always, always, always finish the process by hitting the schema button, and then save your layers. If you got your user layers over here, make sure you save your 3 layers, and then you work through the interpolation process, which is, step 10. So let's take a quick look at step 10, and that is to, I'll set up a folder when we get there. So you just, this is your interpolation button right here. So you click the button, and it's going to give you, what you're going to want to do is set up a location to export your data to. So I've already got one here. I'm going to do channel interpolation test, but I'm going to come in here and hang on a second, coastal training, project export folder, channel interpolation test, and I'm just going to delete all of that data that's below my Flow2D stuff, okay? So I'm going to put that data back anyway. So then I select that channel interpolation test folder, and then you just make sure that this goes to Flow2D Pro and this goes to that folder we were just in, and click interpolate. And now the interpolation process is complete because we now have this output file, and we can click import the channel, and you can import your channel back into your project. And now that the thing to do would be to export and run. And what would happen when you export and run when you're typically working on a channel is that you would get an error message that 2 of your banks are too close, or that some of your banks are too close together. Now, I've already fixed all of that in this channel because I didn't want to get stuck on that. But if you do have problems with your banks being too close together, I have all kinds of videos in my previous tutorials on how to fix that. So I'm not trying to not do that with this class because it's time consuming and we already spending a lot of time on this channel. All right, so we ran through our interpolation and we imported our data again. Now look, this is kind of the beauty of this tool. If you need to come in here and make a change, before you do anything, what you want to do is hit this schema button again. Just going to wipe out that data we just imported, and it's going to reset that channel schema data. And then you can make a change to it. You can add another channel. You can make changes to the banks, whatever, and then run through this process again. Always the last thing you do is run through this process, and then you try that, and then you try your test run again. So now that we have our channel in, that we kind of, this is a point where we kind of want to just start those test runs. So I'm going to what I want to do is, first of all, make sure the channel switch is on. So I got my table here, and I'm going to save this, and I'm going to export my channels back into this folder, and that is, sorry, project exports, channel interpolation test. Select that, and then once that's finished writing the data, which is done right now, once that's finished writing the data, I'm just going to run it, but I'm not going to run it for the whole simulation. I'm just going to run it until the testing is complete, and I'm going to shut the run down. So what I'm doing now is just testing and looking for data errors with the channel. Flow2D is going to check all kinds of stuff with this channel and make sure that it's set up correctly. And see that? That means the tests are done, so I'm done. I don't need to do anything. So I can just shut it down. It's going to give me an error message when I shut it down, but that's okay. It's just because there's no data to plot, or there's no data to write to one of the files. Come on, close down. Yeah, there we go. I'm just going to close. I'm just going to kill it because I don't need it. I don't need the run. And then I'll move this back over, and we can continue on to the next step. Okay. Let's see. Okay, so let's just go over that interpolation step. So we create the chan.dat, exec.dat, and chanbank.dat. And then we save it to the correct folder. You might need to make this folder, that's okay. And then you click OK because those were saved. And then you've run your interpolator. All you have to do is set it to your Flow2D Pro folder. This should already be correct. And then once it's done with its interpolation, you'll know it's done because you'll see this file right here. And then you can import that channel that you just interpolated back into QGIS. So it's an external interpolator. And then we can ignore this. We're going to start with our boundary conditions next. So my next video will cover the channel boundary condition, the tide gates, the export and run, and create a backup. And then the final video will be how to get some data back into QGIS to review the channel.